We have been studying two-factor analysis. That is, we have two categorical explanatory variables and one quantitative response variable. And we've gone through the instructional portion of the videos so that it is now time for me to put it all together to answer my challenge and create a report. Here's the challenge. Analyze the tooth growth data to determine if the type of supplement and dosage of supplement have an effect on tooth growth. There are some scientists who believe that effect of the dosage depends on the delivery mechanism, so check this belief and use this portion of the analysis to make decisions about more specific questions. So, let's go ahead and get started with this. I've got the question up here, and the first thing I'm going to do is load in the data, and I've set that up here to load in the data. When I look at the data, I note that I have characters. Over here I can see supplement is as a character and numeric data for dose. So the first thing I need to do is to turn those into factors. Fortunately, this follows through what we did in the instructional videos, so I can just copy that section in right here. So now when I run this, I see that my tooth growth data now lists two factors, and this is a two-factor study, so this is the way it should be. If I look at the data themselves to make sure everything looks okay, it does indeed look okay, so I am set up and ready to go. The first thing I need to put in here is a description, so let me do that. Here is what I have said. In 1947, E.W. Crampton conducted a study of how vitamin C affects odontoblast tooth cells development in guinea pigs. Crampton used 60 guinea pigs in the study. Each animal received one of three dose levels, 0.5, 1.0, or 2.0 milligrams per day of vitamin C, and one of two delivery methods, ascorbic acid or orange juice. This was a completely randomized two-factor design with 10 guinea pigs in each combination of the two factors. As we discussed in the instruction, a completely randomized design is one in which every participant in the study is randomly assigned to each of the two factors. And indeed, the guinea pigs here were randomly assigned to the dosage as well as the delivery method. I will analyze Crampton's data to determine the effectiveness of delivery method and dosage on odontoblast development. And then here I have two references, so I went ahead and made a little references heading that is going to be smaller than the description heading because I used 5 hashtags. And I have these two references listed down here, appropriately putting in italics where needed with a single asterisk. So that's what I have so far. Let me go ahead and save this and knit it so I can look at it, see how it's looking. And that looks pretty decent. Okay, there is the description right here. All right, now I'm ready to get into the meat of this, and that is the analysis. The first thing I'm going to do is create some box plots. Those will allow me to look at both the center and the variation within each of the 6 conditions. Here I've created the box plot. I start it by setting a model equal for tooth growth length as a function of supplement by tooth growth dose. And then I created the box plot giving a couple different colors here. And I've gone ahead and hidden this code chunk, so all that will come out is the box plot. Now I don't want to start with just this figure. I need some text to go with it. So now that I've got the box plot created, right up above it, I'm going to give it a caption and I'm going to provide some narrative. Here is my narrative. The box plots in figure 1 illustrate odontoblast length for the 6 conditions in the study. Orange juice delivery is depicted in yellow, and vitamin C via an ascorbic acid solution is depicted in green. Two patterns stand out in this graph. First, higher doses dosages lead to longer odontoblasts. So that's what we see in the pattern, the trend going upwards here from left to right. Second, orange juice delivery leads to longer odontoblasts than ascorbic acid delivery with low and medium doses, as we see here with these yellow box plots, but not with high doses. There are similar ranges in most of the conditions, so there is no compelling evidence that some delivery methods and/or dosages lead to either more variation or less variation in odontoblast development. So remember, these box plots are made up each of only 10 guinea pigs, so you might look at, for instance, this orange juice high and say, well, that's less variation than vitamin C high. Indeed it is, but given that we have 10 guinea pigs in each, I'm not making a big deal out of this at this point, although I'll be able to drill down a little bit more when we have our descriptive statistics, and let's go ahead and do those next. Here is my narrative. Table 1 is a display of summary statistics by condition. Average odontoblast growth was as low as 8 microns in the low-dose condition of direct vitamin C delivery and as high as 26 microns in both high-dose conditions. Standard deviations range from 2.5 to 4.8 microns, indicating similar variation across conditions. And you see I've created one table here, and using a technique that I showed you in an earlier report, I'm creating a table that looks like this, but I'm doing it separately for orange juice and for vitamin C by ascorbic acid. How am I doing that? I'm doing that by subsetting. So here I'm creating a new data set called TGOJ for tooth growth orange juice, and I'm subsetting the tooth growth data set to pick out all the orange juice data. And similarly down here, I subset the tooth growth data to pick out all the VC or vitamin C data down for TGVC for tooth growth vitamin C. So I end up with these two tables that, once I turn off these code chunks, can look like they're actually a single table. So if you look at it, it looks like this. Now, it would actually be easier to do this if I was using an external package. GT is my favorite, but I'm committed to using base R in this video, and so I'm showing you how to do this within base R, and it still provides the picture of the statistics that go along with this box plot up above. Actually, in this box plot up above, we have the first 5 statistics. The 5-number summary is what we see in the box plot, but we have some additional statistics that I've added here, the mean and standard deviation, because they're going to go into our primary analysis, including when we're ready to make inferences. So I now have one figure, and I just noticed that this figure does not have italics the way I wanted it to, the figure caption. So I'm going to go ahead and put that on while I'm thinking about it and reknit this and look again. And now I have the figure 1 is in italics, the table 1's in italics. So these give the summary information. Notice that I showed how different odontoblasts can be depending on the condition. The mean can be as low as 8 down here, which is the low condition for vitamin C by ascorbic acid, and it can be as high as 26, which occurs in both the orange juice and ascorbic acid vitamin C delivery. And so therefore we're getting the same mean in both of those, or roughly the same mean, not exactly, but close. Okay, so what do I want to say next? Well, the next thing I want to do is look to see if there's an interaction, and I actually have a good indication that there is an interaction here. We can see that in the box plots. We can see it in the descriptive statistics that orange juice has a higher mean than ascorbic acid for low, it has a higher mean than ascorbic acid for medium, and it has the same mean for high, indicating an interaction. I would like to graphically show this, and although we can figure it out more or less from the box plot, I say more or less because we're not seeing means here, we're only seeing medians, so we could base an interaction on medians. But to focus on means, let's go ahead and create an interaction plot and some narrative to go with that. So let me go back here and continue on and insert right here on line 85 some narrative and an interaction plot. So here is the narrative and the interaction plot. Figure 2 illustrates the interaction in the experimental results. Method of delivery does not appear to make a difference if the dose is high, but does make a difference when the dose is low or medium. In these lower dose conditions, delivery via orange juice leads to substantially longer odontoblast, about 5 to 6 microns longer. So note that this is the effect size at the lower dose, and at the higher dose, the supplement has an effect size near 0, meaning that although high has an effect size over medium and high has an effect size over low, supplement, the effect is near 0 when you compare orange juice and vitamin C. So here is my little plot. I use the interaction plot function. I put in dose and supplement, and you could switch these around to get a different plot. Here's my response variable is the dosage down here. And then note that I said the line type that I wanted is a 1 for each. If you change those numbers, if you made it like a 1 and a 2, then one line would be one type and one the other, but I made them both solid lines, instead choosing to show the differences with different colors. Namely, I did red and blue. And then I turned the legend off so that I could use the legend function here, which gives me more options. It gives me an option of where to put the legend. I put it on the right side. It gives me an option as to, again, the colors, how the title. I made the text in the legend to be about 8%. I actually think that might even be a little bit small. I'm going to switch it to 90% there. I like that better. 90% of what it was. And so now I've gone ahead and hidden the code chunk. So now again, if I save this in knit, we can see how it looks. And it shows us the clear interaction. Again, you could see those in the box plot, but this is going to show us more clearly the interaction. All right, so now that I know that I have an interaction, the question becomes how large is the interaction? And in order to look at that, I need to look at some tetrad contrast. So now I'm going to create some tetrad contrast. Let me come back over here. Let me create some contrast and a little bit of narrative to go with that. I have put in a code chunk here that will allow us to look at all the differences between the means. Remember that the means occur at the junction of the dosage and the particular lines. So we have low vitamin C here, low orange juice up here, medium vitamin C, medium orange juice, high vitamin C, high orange juice. So what I've done here is I've created the differences. Now those are not interaction contrast because those are just differences, not differences in differences. But that's the starting point. The starting point is to look at the individual differences. So this first one here is looking at low orange juice minus low VC, and that's 5.25 right there. The next one is looking at medium orange juice minus medium VC, so this gap here is 5.9. And the final one is comparing high VC and high orange juice, and notice that that's right about 0. Okay, so now we can look at differences among these 3 differences to get 3 tetrad contrast. So here I'm looking at the difference between the difference in orange juice and VC medium and the difference between orange juice and low, and it looks like there's no difference of differences. It's about the same. That's what we saw here, 5.93 and 5.25. So when we take the difference of those differences, we get 0.68. By contrast, when we take the difference in high OJ and VC, which is 0, and the difference in low, which is the 5.25, then we get a difference of 5.3. The difference in differences is 5.3. The easiest way to explain that is it's 5.25 is the difference between OJ and VC. And we can say more specifically than difference. We can say OJ has a higher effect than vitamin C for direct delivery of vitamin C. And there's really no effect when we look at, here it is, no effect when we look at high. So the difference of those differences is that 5.33. And similarly, when we look at medium, it was 5.93, almost nothing. When we look at high, so when we look at the difference of those differences, it's minus 6.01. So taking those numbers, here's how I interpreted this. I am only interested in 3 tetrads to study the interaction among the 3 pairs of condition. First, medium doses of orange juice result in 5.9 microns longer teeth than delivery of vitamin C through an ascorbic acid solution. There's that 5.9. And low doses of orange juice result in a 5.2. There's the 5.2 increase compared to ascorbic acid. Thus, the orange juice benefit is about the same, 0.7 microns. That's right here. That's the tetrad, difference of differences. 0.7 microns difference whether using a low or a medium dose. For high doses, there is almost no difference. Here it is, just 0.1 microns in the effect of orange juice and ascorbic acid. Given that the difference is 5.2 microns for low doses, so now I'm comparing that 5.2 to that almost no difference, the 0.1, this is a difference of 5.3 microns in the effectiveness of orange juice and ascorbic acid as a delivery method for these 2 doses. For high doses, the delivery method does not matter. Again, high doses does not matter. And yet for medium doses, it's 5.93. So I say similarly, there's a difference of 6.0 microns in the effectiveness of orange juice and ascorbic acid on odontoblast development when comparing high and medium doses. So notice that a lot of my interpretation relied on the thing that was easiest to interpret, and that is the difference at each of those different stages. So the reader should come away knowing that orange juice works better for low and medium doses, and it does not work any better for high dose. And so when we make the comparisons about what about low versus medium, well, it's about the same. Orange juice works better, and it works better by about the same amount for low and medium. What about low and high? Well, orange juice and vitamin C are about the same for low and high, but orange juice works better for low, and therefore the orange juice overall is working better. And there's a difference between how it works in the low compared to VC and how it works in the high compared to VC, where there's no difference. So these can get complicated, but hopefully when you read my narrative there, you see how I tried to untangle it for the reader. Now, of course, I want to go ahead and not only hide output, I don't want to show anything. So I'm going to apply this and not show anything. And let me save and knit and see how things are looking so far. And there it is. So we have all the information that I got from looking at those numbers, but then once I got those numbers into a paragraph or 2 paragraphs, then I went ahead and hid that code chunk. At this point, We really are done with our descriptive analysis because I don't want to interpret main effects because I had an interaction. And so now what I want to do is see if I can make inferences. So I'm going to work on that in the next video.